everybody, we're going to talk about graphing linear functions today. Linear functions are exactly what they sound like. They're going to form straight lines. So if you come up with a graph that forms a straight line, that is a linear function. There's two ways to graph these. If you're given some information in a chart or a table, you can use those XY ordered pairs and put your coordinates on the graph first and then connect to make sure they do form a straight line. Or you can use the slope and intercept method, which I feel is kind of a shortcut. It's a nice way to easily graph your line without having to come up with a lot of extra coordinate points. So I'm going to show you both ways. Let's say that we were looking at a chart of values. X is on the top row and Y is on the bottom. What we would do if we needed to find this graph is we would go to the coordinate grid and plot each one of these XY pairs and connect. So let's try this one. Remember, to graph, we're going to look at the sign of the numbers in our ordered pairs. So on this first one, 0, 2, the first number indicates my left-right number and the second one is my up and down number, since first one should be the X direction and second one is Y. So I've got 0, 2. So a little mini lesson on graphing. 0 means I'm going to go nowhere, and 2 for the Y direction means I'm going to go 2 units up. Okay, so nowhere and then 2 units up. This is my final point. Okay, 0, 2. Alright, next point. 2, 4. There we go. 2 units in the X direction, positive means 2 right, and then 4 in the Y direction means 4 units up. So over 2, I'm just going to show you that, and up 4. Okay, so there's my final point again. And continue on. I've got 2, 6. Actually, I believe that should be 3, 6. Okay, let's fix it. And then negative 1, 0. So negative 1 means I'm going to move left 1 and then up or down none. Alright, when you connect your points, you should form a straight line. The reason why I noticed this third point was a mistake was because it was not going to form a straight line. So this chart of values, if it's a linear function, should form a straight line. If you get any points that are off of that line, then it may not be a linear function. Okay, using the chart of values, all we had to do was plot the points and then connect. Using the slope and intercept method, what we're going to do is we're going to start with our intercept, B, they call that B, that's our y-intercept where it's crossing the y-axis, and then we're going to move in the direction of slope, whatever our slope tells us to do, and that's the M. So remember, start at intercept and then do your slope moves. We're going to see this in just a minute. Another thing you can do if you're looking at a function instead of a chart of values is you can test numbers in for X and get extra coordinates that you can plot just like we have just done and then connect your dots. So I'll use this function to show you both of those ways. If you're using the slope and intercept method, starting with the intercept 5, we're going to go up to 5 on the y-axis and put our first point there. And remember to move from that point now. Don't go back to 0, 0. Start at your y-intercept point to get your future points. Alright, our slope is 2. And slope is typically referred to as rise over run. Remember me talking about the X direction and the Y direction? So I like to make slope a fraction. If it's just a whole number, you can put a 1 underneath. So now we've got 2 over 1. We've got a number we can look at for our X direction and a number for our Y direction. So rise 2 and run 1. Rise over 1. Run. So from this point, I'm going to go up 2 and to the right 1, because both those numbers are positive. And you can continue to do this to get your extra points. Okay, up 2 over 1 again, and you could continue until the graph ends. A straight line is going to continue on forever in both directions, so you could go down 2 and to the left 1 to continue on with that line. It's going to go both ways forever. And that's the slope-intercept method. Okay, as I was saying earlier, is I can start with my intercept and move in my slope direction to get my extra points, or I can test values in my function to get points. So let's say I wanted to test 0 and 1 and -1. Okay, what I'm going to do is plug that in for x. So if I put a 0 in for my x up here in 2x plus 5, calculate 2 times 0 is going to be 0, plus 5 is going to be 5. Okay, so I've got 1.05. Try a 1. 2 times 1 is 2. Add 5. I'm going to have 7. And then try a negative number just to get a nice even picture. 2 times -1 is -2, plus 5 is going to be 3. So let's go plot these just to make sure this does form a straight line, a linear function. So 0, 5, I'm going no units and then up 5 units. 1, 7, I'm going over 1 and up 7. And then -1, 3, I'm going to the left 1 and up 3. And it does form a linear function. When we connect, we've got a nice straight line. So again, how are you going to know if your graph is linear? Well, linear graphs have one x in the function, but if you forget that, you can always test those points, just like I showed you, and see if you come up with a string of points that will form a straight line, and if you don't have a linear function. One non-linear example over here is this 2x squared. If I were to test points in this function, I won't show you a whole lot, but I will show you that is going to form a nice curve instead of a straight line. 0, 0, 1, 2, and 4, 8. And then if I continued in the negative direction, it would be a nice little curve. This concludes our lesson on graphing linear functions.